Hello and welcome to the concrete online training. My name is Richard and I will introduce you to the concrete design today for RFEM 6. And yeah, to my person, I work for Dlubal as a product engineer for concrete and also work in the customer support. With me today is my colleague Rebecca. She will answer your questions via chat, but she will introduce by herself.
Yeah, I would also like to welcome you to today's training. My name is Rebecca and I work at Dlubal Software in customer support. And as Richard already said, I'm answering your questions during the training.
Okay, go then. Let's start. Okay, yeah, first the webinar or the training will recorded today, and if it goes too fast or if you want to see it again, it will upload on YouTube. So no panic, all good. So this is the part 4 today, introducing to concrete design. Yes, okay. Here if you have questions during the presentation, you see this panel, and if you have questions, you can enter this here, and Rebecca will answer your questions. And if there are so many questions, we don't get it in this training, we answer later. Or if you have other questions, you can write us under the info@dlubal.com address. And yes, okay. Yeah, how mentioned, this is the 4th student online training. Before there was member design, the R section, and the RFEM 6 introduction. In May 24th and June 14th, there are the timber design and steel design, also very good online trainings, and yeah, you can see them. And okay, but today we have the reinforced concrete design. And yes, I have split my training in 2 parts. First, I will show you an example in concrete beam, so very detailed. And the second part, I show you a concrete slab where I prepared before, and yeah, I show you the difference to the beam design. And okay, yes, that's our model for the concrete beam. It's a restrained beam with cantilever, and yeah, you see the fixed support. And yes, I will show you the design in ULS and SLS, and we will see especially the longitudinal reinforcement and the shear reinforcement. Okay, then let's go to RFEM. We make a new file, new model. It's concrete beam. Okay. The most important when you want to calculate with concrete, you must click here on the add-on button and activate the concrete design. When you don't click this, you don't have the option to see the calculation. So first you must activate this. So to the standards, you have a lot of options for European norm or American, Chinese, Turkey. Yeah, but today I will show you with a national annex of Germany. So, but you see so much annex options. So, but today we choose this. Okay. Okay, the other normal model starts with this dark background. You can change it over display properties. And then here, load dark, load white background. It's better for presentations, so or for screenshots, and yeah. So okay, and I delete it so that we begin complete with an empty model, and we start with the materials. First, we need the concrete, so you choose the material type, concrete, so normal concrete, and okay, C2530. And the second material we must choose is reinforcing steel. We take the reinforcing steel B, and yeah, the B500S with the A class. Okay. Okay, moment. Oh, I have delayed the concrete. Moment. Concrete C25. Okay, good. Then we take the section. We take a massive one, rectangle, and we say 30 centimeter to 45. Okay. So you see, oh, okay, wait, it's wrong. Then I don't want the section choose the material, so we must choose the concrete material. Okay, then you see it's gray, so it's a sign for the concrete. Okay. Then let's start. Our system is 8 meters long. So we choose a new member. Start at the 0 point and go 8 meters. So you see, RFEM automatically makes reinforcement to the beam as a standard setting. First, we make the supports. Okay. So on the left side, we wanted a fixed support. Choose a node. Okay. Fine. So then we want to have. Oh, okay. Yes, he asked for automatic saving. Okay. Oh, I already had it here. We'll call it 1. Good. Yeah, we want to have one 2 meter long cantilever. So we choose nodes on member. That's good because when you choose a normal node, it separates the beam, and when you choose a nodes on member, it doesn't. So I show you. We take it here and 6 meter. Okay, yeah, this point is in blue, so you have a node, but the beam is one beam, so you don't need to set different reinforcement options. The one reinforcement option is over the whole beam. Okay, then let's do the other support. We want to have one roller in X, and because we are in 3D model, we don't want to have torsion, so we choose this. Okay, and choose the node number. Okay, fine. Good. Then to the loads. Automatically as a self-weight load case, which every model you start, it's automatic. So we need some others. The load lever, load cases and we split it in two parts for the inner span and for the cantilever. Okay, then we call it live load inner span with the action category, imposed loads category A. Okay, then let's copy this and give them another name with the cantilever. Okay, so you see the action category, and you have the option to choose another option for the action type. For example, alternatively, it's when you have wind loads from different directions, so you can choose this one, or if you have special combination wishes, you can choose it here, but we let it here. So then okay, one step back, 2 steps. When you see in the base data, you have here the combination wizard, and you should activate this, because then he do the combinations ULS and SLS automatically. So you see the combinations of the actions, and finally the load combinations. So sorry, I don't save it. Again, I float inner span and cantilever. Sorry for that. Okay, so again, here's the actions, the design situations. Now, action combinations and the load combinations. And you see with the gamma values, it combined or load case it automatically, and very nice feature. And here for the information and design situations, you see the rules of the combinations with the gamma values, and see, yeah, okay, fine. So when we have the load cases, we need the loads. For the self-weight, we take uniform load on the whole beam. Okay, with 1.5. Yeah, okay. So, and now to the live loads. We also need member loads, new member load. But this we want only in the inner span. So do not choose load distribution uniform. We choose trapezoidal and take 20 kilonewton per meter. From here, the beam starts from 0, and we have the point at 6 meters, so 6, and the beam 1. Okay. So now you could choose OK, but then the load menu close, and so we can choose apply and next. Then you see we have the trapezoidal load and can switch to the other load case, and also want the trapezoidal load on beam 1 again, but only on the cantilever from 6 to 8. Okay. Yeah, fine. Okay, then load case 3, 2, 1, and automatically the self-weight activate the self-weight of the construction. It is hidden in the display navigator when you go to loads, and here you say self-weight. So this 3.375, it's the self-weight of the beam, and when you change the beam, automatically the self-weight fit. Okay. Then we have our loads. Okay, and now to the special concrete design. You see we have the design properties activated, and this is only possible when you activate at the beginning the concrete add-on. So you see when I deactivate, only main section, notes on member, but we want today design, so activate. Then we have concrete effective length is for the stability design. Today we don't see at this theme, but yeah, it's available. But we go to the concrete cover. There you have the option with a nice picture. You see which different exposure classes are possible. You can choose all you need. Also here some extra options like stainless steel, and yeah, so much options here, but we let the standard, and okay. So then let's go to the shear reinforcement. Here you need the reinforcement steel material. RFEM see it automatically, but you also can here make a new material, but we let the be 500. Then also have the options to change the stirrup type, for example, free legged or with another style. Okay, but we let the standard here. Okay. Diameter 10 or 30 centimeter. Okay. Then we go to the longitudinal reinforcement. The standard option is symmetrical, so but we want to change it to unsymmetrical. We want to have different steels in the top and on the bottom. So we choose on the top 316 and on the bottom 320. Okay. We say okay. Go to the concrete design, and here you see the design situations, the ULS and SLS, all are activated. So you can deselect when you want, or also objects you can choose when you have a bigger model with surfaces, members, nodes. Then you can select them here. Okay. Oh wait, I forgot. Yeah, the longitudinal reinforcement we have. Now to the design configurations. Here you have many options which internal forces are should be in the calculations, or reductions, minimum shear reinforcement, shear joints, and so much more options you can select here for stability. But we let the default here. It's the same in the service ability. So many options. You also crack state detections, but also we let it here on the default mode. Okay. Then for the SLS design situations, we need this design support, and we have a fixed support here. So we need, or we want to have a monolithic connection. Okay, and only in the Z-axis. So we deactivate this. Okay, so all time in this picture, it's actual the actual situation. You can check it here. And we need another support here. So design support at member end would be wrong because the member ends here. So we need design support at eternal node. So we design a new support. Again, only in Z-axis and inner support. Okay, that fit. So, okay, now we have all concrete properties, and so we can start with the calculation. Okay. Here you see the ULS in red, the SLS in green, and okay. So then we minimize it a little. The loads, and we want here in the wireframe mode, and want to deactivate the view on the reinforcement. There you go again to the display navigator and see here under model types for concrete design, you can deselect the reinforcement or in all. Okay. So, Okay. Then we go to the navigator results. I uncheck collapse all, reinforcement on members. There we have 3 options for showing: the required, the provided, and the not covered reinforcement. So we begin with the required on the top and the bottom. Okay, and now we add the provided on the top and on the bottom. Then we see, okay, on the top in this area there is more required reinforcement, so we must add some reinforcement there. And on the bottom side we have enough, so we could reduce the reinforcement, but for this example we let it in this way, but we add it on the top side. Okay, so and this result we can see more easy in the not covered reinforcement. Yes, okay, go here, the top and the bottom. Okay, we see on the bottom there is no not covered reinforcement, so all fits. But on the top, yeah, in this area we need additional reinforcement. Okay, then we go here, longitudinal reinforcement, and we make, okay, a copy, and we say in the bottom we don't need some, and yeah, we see 3.97 6, so little better would be 2, 4.02. Okay, fits better. So when we select the first, we see in yellow, okay, and the second, it's on the same place. It's not possible for the reality, so we make an offset here from stirrup. Okay, and on the left 5 centimeter, and on the right 5 centimeter. So you see, it's much better. Okay. Then through the new reinforcement, the results are deleted. So we must calculate new. Okay. Okay, so again, the not covered. So we see on the top, on the bottom, no problems anymore here. We have enough. Okay, so then we see in the overview, we have another problem, detailing of members in particular rules. Okay, then double click. And now the best in the design. Here you have all formulas. So you don't have a black box. You can control and see every value and check it. So, and here we have this formula, because our VED is too high. There we need another area with 22.5 centimeter. So when we see at 1 meter, we have less force of VRD. And okay, here is enough. And to the support, VED is much bigger. So, okay, back to here. Yeah, we need a tighter area for this. Okay, 22.5. So we go to the shear reinforcement and copy this. So now the program splitted the shear reinforcement in 2 parts. See it in yellow again. And so we only have it in this small area where we need higher reinforcement. So we choose in this yellow, okay, from it's absolute from 0 to 1.5. Okay, so you see, and we want to have the 22.5. Okay, and okay, and now we calculate again. Okay, now everything is green, everything is okay. So no error message. And yeah, your beam is finished. Everything fits. And yeah, here you have all design checks for ULS, the SLS characteristics, frequent, quasi-permanent. So, and yeah, when you want, you can see it in detail, every design check on every location, different members, and the combinations of the loads, or here the design situation. So it's very clear, no black box. You have the best overview over the calculation. Okay. Good. Yeah, that was the first part for the concrete beam. And now we want to go to the concrete slab. Okay. We want to show the slab. And normally you see with the slabs, with L beams, with columns. But I prepared, and we only want to see the slab. And for this, you have following options. Okay, wait, I must open it without results. Okay, so you don't must modeling the walls and the columns. You can do it on this way as line support. Double click. And yeah, here the option stiffness via fixtures wall. Then you have here this tab, and you only need the wall width and the wall height. And yeah, the program automatically do the support springs fitting to this properties. Okay. It's the same for the columns as nodal support. Stiffness via fixtures column. Okay, the dimensions of the section, the column height, and here again the support springs. Okay. Then we want to change from the wireframe model to a solid model. Now we see, okay, the different parts are not fitting together really. So, but it's only a optic thing. We go again to the navigator display. I make again collapse all. Go to the rendering, to the model, solid model, surfaces, and filled inclusive thickness. Okay, you see, that looks better, but not perfect. That's the reason. The reason is that are ribs. You can choose the option under basic objects, member, and here the rib section we activated. And now we see when we go in the solid model, okay, looks much better with the real thickness. Okay, but we go back to the transparent view. Okay. Then, we changed wireframe, it's more easy. Okay, to the Z. So the same like in the concrete beam. Here we have the concrete cover. So you also have the possibility user-defined. I forgot it to show you in the beam model. Yeah, you can manually choose your concrete cover in millimeter, what you want. Okay. So to the concrete design properties. Okay, the directions. The local axis in X we let it. And now to the surface reinforcement. Okay, let me show what I want. Okay, here a new surface reinforcement. And we choose 8 all 15 with additional transverse reinforcement. Also 8 to 15 only on the top. And here again the picture to make clear here the height of the reinforcement. Okay, to number 1 also fit. Okay, we copy this, and for the bottom side we want to have 10 all 15. The transverse direction the same, 10 all 15, and on the bottom. So we have the top and the bottom reinforcement. Okay. Now the design configuration is the same. Here you see only the ultimate configuration because I deselect the SLS here to get faster results, but it's the same like in the concrete beam. Okay, deflection, we let it for the simple example. Okay. Then we start the calculation. Yes. See only ULS. Okay. So again, because it's here we have more objects, I want to show you objects to design all, but I also could deselect some or select only a few members, or okay, service, we have only one here, but yeah, you have the option to select and deselect here. Okay, so back to the reinforcement again, collapse all on surfaces. So this time we choose not covered as first or only. So on the top side, okay, now we see over the columns we have missing top reinforcement. So you can activate the values on surfaces and values on surfaces here on FE mesh points. Then you see, okay, 5, 4. Okay, you see the all values of the missing reinforcement. And yes, we want, okay, or to check on the bottom side, looks good. We have enough reinforcement here, both directions. So we add some top reinforcement here. So we go to surface reinforcement and create new. And now you have the option. We choose a free rectangular reinforcement on the top. Okay, choose 16 or 15 centimeter. Again, 16 or 15. Now we go to direction and location, center and sides of rectangle, and we choose a 4 to 4 meter rectangle. Okay, choose this point and choose this. Okay, yeah, it delete the results again. It's okay. Okay, so now we want to reactivate the view of the reinforcement. There you go to types for concrete design and activate. So that's only the new rectangle reinforcement, but we also can say on surface. So you see all reinforcement with the height. Okay, but we deselect it again, go back to the Z direction, and as a lazy person, I want to copy this. First select, then you go to control, then you see a plus on your mouse, and left 5 meter. Yes, okay. The same again. Okay. And let it make here again. and here again, and one time for the other columns. Okay, so now we have enough rectangle reinforcement copied, and now we want to start the calculation again. Okay, so we deselect one more time the types of concrete design. Okay, again here, and go to the result navigator and see now on the top side it's away over the columns. Okay, some singularity points here, but for this example it's good enough. It's only to show you how to add reinforcement that you don't or that you can solve your problem in this way. Okay. Okay, let me think. Values I had. Okay, yeah. You see here a lot of error message, and yeah, when we would have more time, then we can go point by point, and like in the example before, that everything is green, everything is okay, but for this short example, it should be enough. And yes, okay. Then to the end, I want to make a little advertisement for our homepage. On our homepage, you can see a lot of videos and recorded webinars over every add-on, or nearly every add-on we have. I go back to RFEM to show you again what is possible with RFEM. You see here on the add-ons, so we have concrete, steel, timber, masonry, aluminum. Here joints will coming, and dynamic analysis, and yeah, much more. Okay, yeah, on this, for everything you have, you could watch webinars, very good, from our colleagues. You can get newsletter, see about our events and conferences, can read knowledge base articles and FAQs, which very you get good knowledge. And okay, also the GeoZoom tool, very good tool. You can see, or you can get informations about location, about the snow, about the wind loads and seismic data. Also the cross-section properties. It's a free online tool, so you don't need big books with all section properties. You can find it on our homepage. Yeah, as I mentioned before, the FAQs and the knowledge base. You also have the option to download models, every type of models, and yeah, for inspiration, or yeah, you can use it for free. So yes, also this webinar will upload on our YouTube channel, and there you find every informations and other webinars. And of course, you have the option to get a trial version of all our programs for 90 days for free. And yes, you can test it. You can write to the support if you have a question and can solve a problem alone. You can write us and ask us. We will help you. Okay, yeah. Thank you for listening to my online training, my webinar. And at the end, would very nice when you give me evaluation for my presentation. 1 star is very bad and 5 is best performance. So, or write me some advices. And okay, thank you very much for listening and have a nice day. Have fun with our programs and yeah, goodbye.